You know, when you use something like ChatGPT, it really does feel like magic, doesn't it? But it's not. And today we're going to pull back that curtain. We're going to dig into the insights from the book Hands-on Large Language Models to really understand what's going on under the hood. We're going to go on a journey together, from user to builder. So let's get into it. I mean, this AI revolution, it didn't just arrive, it exploded onto the scene. When ChatGPT launched, it hit 100 million active users in just 2 months. That's not just growth, it's a phenomenon. It proved that large language models, or LLMs, are not just a fad. They're here to stay.
And look, this isn't just about flashy chatbots. As experts like Chris Fragley from AWS point out, this whole field is this amazing mix of really deep theory and practical, hands-on application. And that's exactly what we're going to unpack in this explainer.
And that really gets to the heart of it. It's one thing to use these incredible tools, right? But how do you make that jump to actually understanding them and maybe even building with them yourself? Well, that's the journey we're starting right now.
Seriously, this moment feels like a massive turning point, one that really started bubbling up with early models like GPT-2 and then just burst into the mainstream with ChatGPT. We are literally watching a fundamental shift in how we interact with information and technology.
And their impact, it goes so much further than just asking for a recipe or a funny poem. For coders, teachers, scientists, LLMs are becoming a total game changer. They're transforming how we tackle everything from summarizing dense research papers to translating languages on the fly. Okay, so if you want to become a builder, you gotta know your materials. So how on earth does a computer, which only gets ones and zeros, start to understand something as messy and beautiful as human language? Well, it starts by breaking it down into bricks. This very first step is called tokenization. Before an LLM can even think about what a sentence means, it just chops it up into smaller pieces, words or even parts of words, called tokens. These are the absolute basic, fundamental bricks that the model will use to build meaning. But how does the model actually represent those bricks? The old way was this thing called bag of words, which basically just counted how many times each word appeared. It had zero sense of order. So to it, the dog chased the cat is exactly the same as the cat chased the dog. Not very smart. Modern LLMs use something way better called embeddings. They represent words as points in this huge, multidimensional space, which captures not just the word, but its context and relationship to other words. Now, because these words are now basically coordinates in space, or vectors, you can do math with them. And this is where things get really mind-blowing. What do you think happens if you take the vector for king, subtract the vector for man, and then add the vector for woman? The answer you get is a vector that is incredibly, incredibly close to the one for queen. How cool is that? This shows us that embeddings don't just store words, they store the meaning and the relationships between them. It's like they've created a map of human language that a computer can navigate mathematically. All right, so we have our materials, tokens that have been turned into these meaningful embeddings. Now we need the blueprint, the architectural design that puts it all together. And that blueprint is called the transformer. The transformer, which first appeared back in 2017, was the absolute game changer. See, older models had to read text one word at a time, in sequence. The transformer looks at all the tokens in a sentence at the same time. This parallel approach lets it build a much, much deeper understanding of context, and it's the engine behind pretty much every modern LLM you've heard of. Okay, so we've got our bricks, and we've got our blueprint. What can we actually build? This is where it gets really fun, because the things you can create are, well, the sky's the limit, really. The possibilities are just huge. You can build search engines that understand what you mean, not just the keywords you type. You can classify text, you can get really good at prompt engineering, but one of the most powerful techniques that people are using right now is something called Retrieval Augmented Generation, or RAG for short. RAG it's just genius, and it's so simple. Instead of just asking the LLM a question cold, you first have your system go and find relevant information from your own private documents. Then, you literally just stuff that information into the prompt. Finally, you ask the LLM to generate an answer based on the facts you just gave it. It's like giving the model a superpower, access to private, real-time data it was never trained on. Now, a great builder, a true craftsperson, doesn't just use parts off the shelf. They customize them, they refine them. So how do we take one of these giant general-purpose LLMs and make it an expert on our specific tasks? The answer lies in a set of techniques called parameter-efficient fine-tuning, or PFT. This is basically a collection of clever tricks that let us adapt these massive models without the insane cost and time of retraining them from the very beginning.
Think about it this way. Trying to fully fine-tune a model that has billions of parameters is like deciding to repaint an entire skyscraper just because one new tenant moves in. It's ridiculously slow, it's crazy expensive, and it takes a ton of computing power. So, a much smarter method is a PEFT technique called LoRa. What LoRa does is it freezes the huge original model, doesn't touch it, and just injects these tiny new trainable modules. It's like adding small, easily changeable signs to that skyscraper instead of repainting the whole thing. You get the customization you need by only changing a tiny, tiny fraction of the original.
And to make things even more efficient and accessible, builders are now using something called QLoRa. This combines LoRa with a compression technique called quantization. Quantization basically reduces the memory the model needs to run. It's kind of like telling time to the nearest minute instead of the exact second. You lose a teeny tiny bit of precision, but you gain a massive amount of efficiency. So we have the materials, we have the blueprint, we even have the tools for custom finishing touches. But with all of this incredible power comes an equally incredible responsibility. Building with LLMs is not just a technical challenge, it's an ethical one. As a builder, you have to think about some really tough issues. These models can just make stuff up. They hallucinate. The whole idea of who owns AI-generated text is a huge legal gray area. Governments are already stepping in with regulations. And most importantly, for any serious application, you have to be able to verify that what the model is telling you is actually accurate. So look, we've gone on this whole journey, from the explosion of the AI revolution to seeing how language gets turned into bricks to understanding the transformer blueprint that puts it all together. We've even looked at the craft of fine-tuning. You now have the foundational knowledge to go from being just a user to thinking like a builder. So the only question left is, what will you build?